ان الريسبتورز اللي هنتكلم عليها دلوقتي within few years it will be the topic of interest. طبعا احنا ما عندناش حد هنا ضيوف اجانب، فهنتكلم بالطريقه البلدي بتاعتنا، نص عربي نص انجليزي. فندم؟ في؟ You have some foreigners here? Huh? Malaysian, okay, no problem. Just, it's okay. So pain physiology is, as we know, a complicated process. It has different types of normal sensation and abnormal sensations, thermal, chemical, mechanical, and localization discriminations. In the meantime, there is certain aspects of pain or pathological pain, like neuropathic pain, inflammatory, and psychogenic pain in nature. To fulfill or to proceed or to execute this pain physiology or complicated pain physiology, we are in need of complex pain mechanisms. We have numerous transmitters, and consequently you have more and more receptors. Actually, I'm interested in this type of slide because it will sum up the story as pain on the top, and you have a balance. Certain transmitters and receptors will induce pain, and others receptors and transmitters will inhibit this pain. I'm going to have very rapid revision on these types of receptors and the transmitters, just for enumeration and just to remind each other with it. We have that on the top of the row, peptidergic receptors carried on by the substance P and the calcitonin gene-related peptide, NMD receptors stimulated by excitatory amino acids, glutamate and aspartates, AMPA receptors like alpha-methyl propionic acid, kainate chi-squalate receptors also by specific or by substance P and calcitonin-related peptide, and ionotropic receptors or voltage-gated receptors responsible about sodium and calcium influx inside the cells. Cholecystokinin B receptors, and this is with some metabolites of opioids. Nitric oxide and its consequence in production of pain physiology. Pain inhibiting factors and receptors also on the other way of the balance, the other arm of the balance, we have the opioid receptors, mu, kappa, delta, stimulated by the natural or endogenous ones, endorphins, enkephalins, and dynorphins, or the synthetic group. This is, you can't say that this is synthetic, but now it is manufactured in a way. So you have morphine, petidine, or fentanyl, or we can group it as external or exogenous transmitters. We have GABAergic receptors transmitted by midazolam and the baclofen, gabapentin, and the pregabalin. And this about the capsaicin or vanilloid receptors 1 and 2, and they are stimulated by the natural capsaicin of the pepper, red pepper, or the infratoxin, which is a synthetic one. Alpha-2 adrenergic receptors like norepinephrine and clonidine, and the new drug dextrometidine. More and more inhibiting factors and receptors like serotonergic receptors, calcium channel blockers, ionotropic receptor blockers like calcium channel blockers like nimodipine and verapamil. You have also sodium channel blockers like local anesthetics, mexilitine and carbamazepine. And another natural ions, voltage-gated ions, but on the peaceful side, like potassium and magnesium, they are inhibitory in nature. The dorsal root ganglion still has its own receptors and its own physiology in the form of galanin receptors, neurokinin 1 to 5, and we have vasoactive intestinal polypeptide. Actually, we have to look here at 1 to 5 receptors, and this is a very important point because you have now the transmitter, and you have a subgroup of the transmitter. This subgroups means that each subgroup is responsible about target receptor to work on. So if you have any drug and it has so many sites of action, each subgroup is specific to this site of action. So I can give you another example with serotonin or 5-HT. It has A and B and A1, 2, 3 and B1, 2, 3, about 15 subtypes of serotonergic receptors, and each one is working, some working on the vomiting, one working on the intestinal, one working on the spinal cord. So actually the exploration of subunits or sub class of the receptor of the transmitter is going now more and more widespread to explain why each drug or each transmitter has wide mode of action and different places of the body. More and more pain-producing receptors like bradykinin 1 and 2, and still bradykinin is working in inflammation, but as far as I know, bradykinin 1 is not yet well understood, while bradykinin 2 is responsible about sensitization of silent receptors in normal resting stage at physiological basis. All our nerves or our nociceptors are not working 100%, about 20% is working, and the other 80 are in deep sleep, in coma. But once you have certain types of pathological pain, there is a wind up, or everybody will wake up, and the transmitter responsible about sensitization or waking up of this silent nociceptors is the B or bradykinin B2. Tyrosine kinase also affected by nerve growth factor, and nerve growth factor has so many physiological functions, especially for development of the embryo and actually for mast cell degradation in cases of anaphylactic reaction and so on. And also it works its share, or it takes its share to sensitize the sleeping silent receptors. More and more analgesic receptors are actually coming, which are nociceptin or orphanin receptors and transmitters, and they are grouped as being opioid-like receptor, ORL, but they are not lacking, they are lacking the analgesic properties. So they are present actually nearby the marginal zone of the spinal neurons, but it has more and more neuroendocrinal secretion function. It works also with emotions, with hearing, so it is opioid in nature, but not of analgesic functions. If you apply the opioid agonist on the nociceptin receptors, you got no effect. And if you are going to put the orphanin-like receptors or the opioid-like receptors on the mu kappa delta, they have no effect also. So you have something like cousins or twins, but not identical in nature. But now, that's actually a revision of the well-established ones. Coming new in the market now, as an example, actually, I'm sure there is a lot, to my knowledge, there is a lot, but maybe I'm happy with these 4 types of receptors and transmitters. You have toll-like receptors present in the glial cells, and that's actually a new field that we have neurons responsible about transmission of nerve impulse, and we have glial cells. And the glial cells are just present like that for nothing. They have certain function. I'm going to tell you about them. You have calcitonin gene-related peptides, and they have his own receptors. Before that, we think that calcitonin gene-related peptide is just a co-transmitter with substance P, but he has no more role. Now he has his own share to do. Endocannabinoid system, or also receptors like cannabinoid 1 and 2, and something coming relatively in cancer pain problems, which is endothelin receptors. Here the glial cells, and they are branched cells like that present in the central nervous system, and we have to remind ourselves with the functions of the glial cell, that they have no role in the neurotransmission, but they are doing housekeeping in the normal language or the common language. But to make it scientifically, it is the glial cells are responsible about the homeostasis of the neuronal function. They are going to surround the neurons and hold them in place, supply nutrients and oxygen, to insulate one neuron from another by more and more myelin sheath production, and to destroy the pathogens and to remove any dead neurons. So like macrophages in a way. But actually the triggering factor for them is calcium channels to start this problem. Once they feel tissue injury, it means there is neuronal or cell damage, so potassium will be free, and this is a good signal for the glial cells to start acting and to be active. And here is the resting stage of the microglial cells, and here after it do its housekeeping activity, very well swollen and full of debris. I think I'm not in need of this. Yeah, that's it. Now, in case of nerve injury, you have to start the nerve injury, then the glial cells will be activated, so prostaglandins and oxygen radicals will be released with interleukins of different types, with tumor necrosing factor. This will do upregulation of new class of receptors called purinergic receptors. We call them the P2X, and that's the abbreviation for this new class of receptors. And they are going to go into release of more and more biochemical reaction like nitrogen active protein kinases, and then brain-driven neurotropic factor. Actually, for this classes working for candidates going into the MD in pain, but just for knowledge that we have, the nerve injury will start on this type of closed circuit until we have release of more and more transmitters, and this will end by neuronal hyperexcitability and establishment of neuropathic pain, in addition to the other mechanism actually present in other pain. And that's where I'm getting this information, because I have to be honest with the authors. So now, what are the receptors acting on these glial receptors? Certain transmitters and the receptors. We have toll-like receptors, and that transmitter is toll-like 4. Actually, it's not yet well organized things, but they have another code numbers also for plate 1 transmitter on these receptors, and so many abbreviations here, very long name, but still it is antagonist to the function. So you can say that these two classes are showing or possessing certain analgesic properties. And you have tumor necrosis factor and actually down-regulation of the previous mechanism I told you to this. We have down-regulation of these two functions. So once they are slow in function, you mean that you are do more and more against pain. And you have synthetic things like minocycline as a tetracycline with chelating agent function as a calcium channel blockers, and nitroglycerin, which is actually a synthetic drug and working now. Corticosteroids also can do its work, and you have a very long list as a microglial inhibition factor. So by this you can have, or to know that the glial cells are responsible and take its share in the production of the neuropathic pain. Not the only factor, as I said, because so many factors are available now. In the meantime, you can antagonize this role by more and more drugs, and I'm sure that within few months and maybe this year, they have new formulation of drugs. And this is not the end of the story, but you have also the calcitonin-generated peptide. Actually, they found that this calcitonin-generated peptide has high concentrations in cases of persistent pain, allodynia, and migraine. Actually, it takes its share to activate the glial cells. Calcitonin plus substance P inhibit peptidase enzyme. So we say that for a long time that substance P is a very weak and transient transmitter. But to work and to give us the pain signal, should have an umbrella or a protector or a strong person to guard or to guard him from being metabolized by calcitonin-generated peptide, which inhibit peptidase receptors. So it gives some time for substance P to work, and also present in the caudal part or the spinal part of the fifth cranial nerve nucleus, and this will be actually responsible about migraine. But still, in other places out of the scope of our work here, calcitonin-generated peptide have or has certain analgesic functions. Maybe now we are going to deal with subclasses or subunits from calcitonin-generated peptides. In certain places it works as anti-analgesic or pain generator, but in other places it works as pain inhibitor. So you have this antagonist of calcitonin-generated peptide, and they are clinically used now. Olcigepant and the telcigepant, they are new drugs, and they are active to prevent and abort migraine attacks, but they have some disadvantage like short duration of action, nausea, vomiting, dizziness, and increased liver enzymes. The trial is going on to have something more safe. Now we are going to the third class of the endocannabinoid receptors, like cannabinoid receptor 1 and 2, and they are present centrally and peripherally in the central and peripheral nervous system. The endogenous one will be anandamide and arachidoryl glycerol 2-AG2 and AEA. They are very good, and they have very good functions in improving the appetite, mood, memory, and potentiation of analgesia. So the exogenous agonist is cannabis, and I think Dr. Bolla said another thing is called the hash. So you can give me more and more demonstration about this hash, Professor Ahmed. And now you have mechanism of action of these cannabinoids. They act on the spinal cord and stimulate inhibitory pain pathway, stimulate production of GABAergic fibers, and noradrenaline fibers will result, noradrenaline transmitter will result in more analgesia in the descending pain pathway. The last one is the endothelin receptors. They are present actually in so many subtypes, and also more and more receptors, and they are originally responsible about the production of essential hypertension. But they found that endothelin 1 is present in high concentration in methylated form in cases of oral carcinoma. So they found that there is some association between the elevated methylated endothelin transmitters and the coincidence of high or coincidence of presence of oral carcinoma, but not in oral dysplasia. So they found that there is certain association between them and actually for the production of pain problems. Actually, there is certain drugs now to antagonize its function, like bosentan, and this bosentan actually is clinically used, but still it has certain disadvantages like the other drugs, and they are going to be more and more promising for production or for prevention of cancer pain management. This is my home message, and I'm not going to fed up or to give up to say these phrases for in every place, that pain physiology is complex process. We have different pain generators and pain inhibitors. No single mechanism will cause pain or analgesia because we have so many transmitters and so many receptors. More and more receptors and transmitters will be discovered every day, maybe every hour, and at last maybe we are clinicians who said why we are going to trouble ourselves with this basic knowledge. I can say, and I insist on this, good physician should be good scientist or good basic scientist. Please don't be just a clinician, or you will be a technician, not a pain doctor. Thank you very much.